Welcome to RichPlanet TV. I'm Richard D. Hall. How much of what you learned at school was true? In today's show, I am going to be discussing with Andrew Johnson a new theory about the development or the creation of planet Earth, and possibly all planets. Many observations about the Earth over decades have puzzled scientists who have concocted theories to attempt to explain what they observe, including theories such as plate tectonics, or the Earth's core is made of iron, or the primordial Earth was much hotter than today, etc., etc. Now, if the new theory we are going to talk about today is true, it means many textbooks will need to be rewritten. I'd like to welcome onto the show Andrew Johnson. Welcome back, Andrew.
Great to be back here, Richard, in the new wonderful studio. It's very impressive. Thanks for inviting me.
Okay, now, some people occasionally say, well, why do you keep having the same guests on, Richard? And I would answer that by saying, well, because the guests that I have on always talk about something new. Okay, you've done a lot of research into 9/11, the moon landings, Mars, and we've covered many issues. But this is a completely new area, at least for RichPlanet, and I think it's a fascinating theory. And we're going to mention the work of Peter Woodhead as well, who you've been collaborating with. Now, what impressed me about this theory, Andrew, is that it seems to explain many loose ends about our planet and possibly other planets. And I'm just going to list some of them that I've picked out when I've seen the interview that you did with Peter Woodhead, and also the papers that you've written with Peter Woodhead. Now, I think it could explain why larger planets are gaseous or become giant gas giants. It explains why the gravity of the Earth was much less when the dinosaurs were around, which a lot of people think. It explains that in the past, when the Earth had less gravity, when the dinosaurs were around, but the total mass of the Earth was still the same. It explains why some of the oceanic plates are relatively young. It explains why the Earth has oceans. It explains how the continents formed, and it also explains why the continents all seem to fit together. Now, but before we go into the actual theory that we're going to discuss today, just give us your understanding of what the accepted theory is on how the Earth came to be, where it is, like it is.
Right. Well, I mean, you know, what I remember reading about many years ago, and I have to obviously point out that I'm not a geologist, I'm not a planetary scientist, as we've discussed before, Richard. You know, my background is in software, although, as you said, we've investigated these other things together in these various programs. So, you know, if I get some things wrong, then please forgive me. You know, I wish I knew everything about these topics, but I don't. But my understanding of, for example, how the Earth was formed is that there was a large accretion of mass from which the sun and the planets either formed or were forming, and that was initially largely, you know, hot mass, and then at some point the Earth formed into a distinct body which was still very hot, and you know, you had periods of hot material, a globe of hot material essentially, and during a period around that time there was what they call bombardment, where you had these lots of debris flying around, you know, which was making up the other planets, the moons and so forth, and that was repeatedly coming by and crashing into the Earth, and a very kind of hellish environment, and we ended up with what allegedly we have now, which is a fairly cool crust, outer crust, and then we have, you know, a breathable atmosphere. And then if you go further down, you know, if you were to drill down through the Earth, you'd go through the sort of layers of rock and so forth, and then as you went down, it'd get hotter and hotter and hotter. And then my understanding is that they say we have a molten core of iron. The core of the Earth is molten iron, because the story is that the iron is heavier than a lot of the other elements, and it's ended up basically at the core of the planet, and it's essentially liquid. And my understanding is that the reason, one of the reasons why they say that this is the correct model, is because that gives the Earth its magnetic field. So in other words, this molten core is in whole or in part responsible for producing the Earth's magnetic field.
Right. In this diagram that you referred to there, that we see in many, many textbooks, you think is possibly completely incorrect.
Potentially it is,
potentially.
Yes. Yeah.
Now, let's briefly talk about Peter Woodhead, because really he contacted you with this theory, and his theory was built upon two other researchers.
Yes.
They are James Maxwell, is it?
Yes, correct.
And Neil Adams. Now,
essentially, yes.
right. But Peter had actually, well, his theory is different in one very fundamental respect to their theories. We'll
go through that.
We'll explain their theories in a moment. But one thing that, because I've met Peter as well, Yorkshireman, and I think he's from Yorkshire.
I don't know. It's Lancashire.
Lancashire.
So, yeah.
I'm going to get wrong for that.
Yeah.
It's on the Yorkshire border somewhere.
Yeah, it's close to Yorkshire.
Yeah.
Not quite near my old stomping grounds, actually. Yeah.
Right. Now, Peter said that he'd watched one of my shows where I interviewed Keith Hunter.
Yes.
Yeah. Now let's, and you can watch those interviews. They're programs number 62 and 63 on RichPlanet. But just briefly, one of the things that Peter was interested in, that Keith Hunter was talking about, were imperial measures, the system of imperial measurements. So we've got the inch, the foot, the fathom, which is 6 feet, and then the mile. And what Keith Hunter suggests is that those measures go back eons. No one really knows at what point they were invented, but when they were devised to fit harmoniously in with the dimensions of the planet, i.e. the equator. And what Keith Hunter asserts in his book is that if you split the Earth up into 360 degrees around its circumference, and then each degree into 60 minutes, you get a minute of an arc around the circumference. And each of those minutes used to be perfectly 6,000 feet, or 1,000 fathoms. So the entire circumference of the Earth would have been 21,600,000 fathoms, right? And everything fits into now he gives quite a good reason why he thinks that, and it's to do with the 360-day year, because Keith Hunter comes up with a ratio between the 365.25, whatever it is, days that we have in our current year, and he divides 360 over that to come up with this 1.15 ratio, and he multiplies that by the current circumference of the Earth. And he comes up with a new circumference of the Earth where, strangely, the circumference is exactly, or 1 minute of arc fits exactly into 6,000 feet. So what Keith Hunter would say is that at some point the Earth's circumference was 1.15 times less in distance. It was smaller physically, and that's possibly around the time when the imperial measure system was introduced, which could have been millions of years ago, for all we know.
Possibly.
So that's where Keith Hunter's coming from on this, and Peter Woodhead was scratching his head over that, and he'd seen other researchers such as James Maxwell and Neil Adams. Now, can you start, Andrew, by telling us what James Maxwell and Neil Adams are famous for in their research first, and then we'll point out what Peter Woodhead's modification is on that.
Yeah, so Neil Adams and James Maxwell, they have looked at this idea totally independent of Keith Hunter, that the Earth was a different size in historical times, and it was actually smaller. And they've come at it in slightly different ways, and I know from correspondence, certainly with both of them, that Dr. Maxwell, he is a geologist, PhD geologist, so he's thoroughly scientific. And Neil Adams is an artist. He's actually a comic artist, and still, to my knowledge, he does a lot of work in that area. And I actually did an interview with Neil Adams quite recently, actually. because as a result of developing this theory with Peter, Neil Adams, we'd agreed, I got in touch with him and he wanted to do an interview to basically try and explain why we must be wrong. But they came at it separately. Dr. Maxlow had done a lot of geological research. In fact, he did his PhD on this idea that the Earth was historically a different size, different circumference from what it is now. And he'd done a lot of models on this, and he'd looked at various geological records. And Neil Adams had actually made some CGI animations which illustrate this very well. And these have been on YouTube for I think almost 10 years now.
We can put a link up on the screen to these
right.
Two researchers' research. Yeah.
Yeah, absolutely.
Right.
And you look at these animations that Neil Adams has produced, and they've got a lot of hits. I think quite a few people have become aware of them in the last 8, 9, 10 years, and they are very well made. He produced at the time in his own studio. He had a digital animation studio which he'd set up himself for his own productions, and then he'd utilised that to produce some of these animations. And this visualises what we're going to come on to very powerfully, I would say. And then what I should say is there is a history to this which ties in to a large extent with the standard model that we're going to also talk about, which is plate tectonics, which you'd mentioned. And I studied that. Well, I was shown that in geography at school. I did about plate tectonics. We'll explain what that is as well. Right.
All right. Well, we'll go for our first break now, and we're going to expand more on this shortly. Welcome back. I'm talking to Andrew Johnson about an alternative theory of how the Earth was formed. Now then, let's just go back and look at what the science books say. Tell us about continental drift and how that was considered in the early 20th century.
And this, I think, goes back even to the 19th century. Somebody had observed, that the continent of South America seemed to kind of like be a bit of a jigsaw puzzle that fits with, the African continent. And so then somebody came up with this idea, well, maybe these continents have actually been moving over time, and people said, no, that's ridiculous, because the Earth has always been here, God created it, it's always been like this, it's never changed, so that can't be right. And then there was a chap called, I think his name was Alfred Wegener, in about it was the early 1900s, I think it was 1912 or 1918. He proposed this idea of what was called continental displacement, and which then was renamed because people didn't like this idea of these land masses sort of moving around. Now, that doesn't happen. And they called it continental drift as a way of kind of ridiculing it, or partly ridiculing it, because displacement is a more scientific word, and drift is kind of like, oh, you're just drifting around, don't know what you're talking about, And so there's a bit of language issues used there, and we're all very familiar with how that works, aren't we? But then it was actually, they started to measure this, that the continents were actually moving apart, and you've heard the statistic that, England and America are getting 1 centimetre, or whatever it is, further apart every year. And that was then measured, I think, in the sort of mid 20th century, more or less. And then they thought, oh yeah, the continents really are moving apart, so that's when it's called continental drift. And then they came up with this idea that what's actually happening is we've got this kind of semi-solid inner Earth, or surface layers, and then floating around on the top of that we've got these more solid layers, and that we've got these plates. In other words, the Earth's crust is made up of these plates, and these are floating around, sort of on a kind of the liquid mantle, which is where all the lava and stuff comes from. That's underneath. It comes through the mantle. And that's sort of slightly lower down. And so all these continents are moving around, and that's where we get this idea both of continental drift, as it's called, and plate tectonics. And then I suppose the next development of that was where they looked at the mid-Atlantic Ocean, and they found that on the seabed of the mid-Atlantic Ocean, they'd found these ridges, these hardened ridges of essentially lava that had solidified over hundreds of thousands of years, and basically there was this spreading, the ocean floor spreading. It was spreading from this central fault line, which was volcanically active, and they've sent submarines down there and filmed all the volcanic vents, and there's various things going on down there. And then they were also able at that time to measure the age of this ocean floor spreading, and measure how quickly it was happening, because what they observed in this rock, there were ferrous materials which had become magnetized due to the Earth's magnetic field, and they noticed that this magnetic field had flipped. I forget the exact figure, but every so many tens of thousands of years, or hundreds of thousands of years, and so they're able to age how old these parts of the seabed were. So this is one of the key studies that was started in the 1950s, and they did various surveys around the world and looked at the ocean floor, and they measured the age based on these magnetic field reversals. And the very peculiar thing that came out was the oldest ocean floor that they could find was dated to around about 180 million years. So even if you go right to the coast of America, the east coast of America, or the western coastal parts of Europe and Africa, the oldest ocean floor is only 180 million years, whereas the age of the Earth is estimated to be about 4 billion years old, according to all the geology textbooks. So that presents you with a bit of a problem, because the ocean floor is much newer, by hundreds of millions of years, than the rest of the geology on the planet. So then they sort of said, well, if these ocean floor is spreading, and we've got the continents moving apart, then what must be happening somewhere else that we can't see is that the continental plates must be going under another of the ocean plates elsewhere on the planet, because then the ocean floor stays the same size and the Earth stays the same size, and what we're getting is subduction. And so the continental plate is being forced under either another continental plate or under an oceanic plate.
So this is a generally accepted geological phenomenon called subduction.
Subduction, correct.
Right.
That's one of the key things.
Which really is a theory.
It is essentially a theory. Now, they'll claim that there's certain evidence for this in the Far East, and they say that there's subduction going on in some of the areas there, and they can prove that this is where the continental plate is being destroyed, because it's been subducted under another plate, and it's going back down into the lower areas of the Earth.
So let me interject there. So they're trying to explain the phenomenon without having to say that the Earth is expanding.
Yeah, essentially.
Right. Now let's just look at a few other areas that have geologists, or I don't know what you'd call them, paleontologists, scratching their heads, and that is finding things that should belong at the bottom of the ocean on the top of mountains, such as fossils, and also the physiology of dinosaurs.
Yes.
Just tell us about that.
I mean, everyone knows, everyone's taught at school, probably in primary school, that dinosaurs were huge creatures. There seems to be good evidence for this, because we have skeletons, and they've reassembled these, and they're in the Natural History Museum, and they're huge. The Brontosaurus. You think, wow, these things are amazing, and you're fascinated as a child by these things. But then, when you start to look at this, you think, well, hang on, if this was at least a bit like some of the creatures we have now, then how did it live? Because, for example, if you calculate the required pressure to pump the blood from the animal's heart up to its head, the heart would have need to have been so big, it wouldn't have had anything room for anything else in its body almost, because of the pressure that you'd need. But even, I think, more simple to calculate is things like weight ratios. If for example, you calculate the surface area of the foot on the ground, and then you calculate the weight that foot has to support of the animal, as you get bigger and bigger, you find that the dinosaurs' bones and feet and so forth could not have supported the animal's weight based on the force of gravity that we have now. So if you do the calculations that you say you would do for an elephant or a giraffe or something, the dinosaur is no longer viable. The problem becomes even more severe for the dinosaurs which flew, because the problems that you have there is that, you know, power to weight ratios, wing surface areas and that sort of thing, they're much more extreme than for land animals, where you're dealing with, you know, mechanics and mechanical areas and that sort of thing.
So that whole observation suggests that the force of gravity was possibly less, say, 100 million and more years ago.
Correct.
Right.
Correct.
Now, what about oceans then, and things that are found in areas perhaps where they shouldn't be? Tell us about that.
Well, of course, that's another interesting area. I mean, I remember being set this question in geography, or this question came up in geography class. Where did the oceans come from? You know, you read the textbooks about the dinosaurs, for example, and they all say, in the time of the dinosaurs, there were no deep oceans, only shallow seas. So one of the big geological mysteries is where the deep oceans came from. How did we get those? And that's not really explained very well. You'll hear, for example, talk of, well, there's two problems. One is how come the oceans are so deep, and the second problem is where did all that water come from? And, you know, people will say, for example, that comets, the water came on comets, these balls of ice which were in the primordial solar system, and we had hundreds of thousands of these comets crashing into the Earth, and they brought all the water. But that doesn't really, if you forgive the pun, hold water when you start to look at all the problems with that theory and the volumes and so forth.
So some people have put forward that if Earth's gravity was less in the days of the dinosaur, going by Isaac Newton's gravitational law of gravitation, F equals J m over r squared, they say that, well, there must have been less, the Earth must have been less massive.
Correct.
To have a less gravitational pull on
Correct.
the dinosaurs. So therefore, they come up with the theory that the Earth has not only been expanding over millions of years, but actually gaining mass.
This is one of the,
more stuff has been added to it somehow by some magical process. And am I right in thinking that both James Maxwell and Neil Adams both support that view?
Correct. That's one of the key issues that when we get onto Peter Woodhead's ideas in more detail in a few minutes, that's one of the sort of nubs of the problem. That James Maxwell, who has done a lot of geological research, which to me at least proves that the Earth must have been a different size in the past. It must have been smaller. Right. As you say, he thinks the mass was also lower and the mass has increased. So we've got this extra mass which has made the force of gravity now much stronger than it was in the time of the dinosaurs.
Right, and that's where Peter Woodhead comes in.
Yes.
Because he says, no, the Earth's mass has been constant.
Correct.
But it has been expanding. And we'll explain how that works after this break. Welcome back. I'm talking to Andrew Johnson about the creation of the Earth and the new theory which suggests that the Earth has expanded from a much smaller sphere but has not gained any mass. Now, this is Peter Woodhead's idea, and
yes.
You met Peter Woodhead, what, about a year ago or something like that? Or
yeah, it's a bit longer than that, but yeah,
so
essentially.
just tell us what conversations you've had with him in developing his theory.
Well, you know, this was the thing. I'd agreed with Neil Adams and Peter and James Maxwell that the Earth must have been a different size in the past. It must have increased in circumference, in radius, and so forth. And Peter wrote to me. I think he'd seen me on RichPlanet actually, and we talked about Keith Hunter, and Peter had watched that program, and that set him thinking. And then he says, "Oh, Andrew, I've got the explanation for how the Earth has expanded." And I thought, "Oh, that sounds interesting." And eventually I was able to meet up with Peter, and he sent me some of the calculations he'd been doing, because he has made some calculations, which we may talk a little bit about, although they're not essential to describing this theory. And it is a theory, but I think there is sufficient evidence to back it up that I think it is probably correct. He'd seen some research about looking out into the distant sort of distant parts of our galaxy, or the stars in our galaxy, and astronomers in Atacama, they call them the Atacama astronomers, a team in Atacama, they'd observed what they called a snow line around a star. So they had a star in the centre of this solar system, and around this they'd observed a sort of ring of frozen water. And I think this idea was mentioned in this article about this snow line around this star, that the planets were forming there. So Peter thought, well, hang on a minute then. Maybe that means that when the Earth formed, it wasn't all this hot bubbling, mass, from that was spat out of the sun or whatever, or spun off from the sun, or accreted from various rocks that were floating around, crashing into each other. Actually, what was there was primarily ice, and it was formed from a lot of ice. And then around the ice, you had the rocky layers, the heavier elements, the metallic elements, and so forth. Obviously, everything we've got now. And so that formed into a globe, and it was a smaller globe than it is now, and but essentially it wasn't this primordial fireball. It wasn't like that. It was much cooler than that, and maybe not, a lot of it wasn't that much hotter than room temperature. And what Peter has argued was that actually the core of this ball of the Earth was actually ice, and it actually was, physically a solid block of ice. And so you had the ice in the core of the Earth, so we started off with an ice core, and then around that you had this rock and these heavier elements, including radioactive elements, for example. Everyone knows that radioactive elements are a source of heat. And so you get in that radioactive heating, and Peter's cited some articles which show that a large percentage of the heat in the Earth's crust comes from radioactive isotopes. So there was that. So what you've got is radioactive isotopes around the ice core, gradually heating up the core. And there's a limited place this heat can go. It goes into the core. And what James Maxwell observed is that for up until about 300 million years ago, there was no Earth expansion. That from the geology that he'd done and looked at, James Maxwell said there was no Earth expansion until about 300 million years ago. And then all of a sudden, boom, it starts expanding. And it expands exponentially as well. So what Peter argues in his article is that the ice core, over billions of years, in fact, 3,700,000,000 years approximately, the ice core had gradually melted, turned to water, and then the heating continued, and then 300 million years ago, the water in the core started to boil. So that boiling water then started to create pressure, and then that began to make the outer layers expand, and that's why the expansion only started about 300 million years ago, and it's still going on today.
Now, this is all spinning as well.
Yes.
And you cite a NASA experiment which has clearly been done in zero gravity of a sphere of water, a solid chunk of water in a sphere, as it would be.
We'll show this video, yes.
In zero gravity, which is spinning.
Correct.
Which is water in zero gravity spinning.
Correct.
Which is similar to what he's saying that the Earth started as.
Yes.
But they inject some solid material into that as it's spinning.
Yes.
And just explain what's going on, Andrew, in this clip.
Well, if you look at that clip, it's I think they explain it in the clip itself. You'll see that the heavy materials actually go to the outside, and if you take this droplet of water, maybe it's just like a teaspoonful of water, and you can add to it because you're in zero gravity. You can make this sort of globule of water bigger, and it does form a perfect sphere. You inject air bubbles into it, and the air bubbles don't come out and fly out. They actually go to the centre. So the lighter materials end up in the centre of this droplet of water. Mm-hmm. So we're saying that what actually happened with the Earth was when these when the water started to boil and become water vapour, although we got pressure, some of those gas bubbles actually ended up in the centre of the Earth, because what we argue is that the way that gravity works inside the Earth is different to what the textbooks say. Right.
Now let's come on to that then. So the two researchers that we mentioned earlier, James Maxwell and Neil Adams, are saying, well, if the Earth is growing in its circumference, there must be some more material being put in.
Correct.
Whereas Peter's saying, no.
Correct.
It's changing its topology, if you like, i.e. there's something in the centre which is pushing the mass out like this.
So the mass distribution changes, correct.
Right. Now, wouldn't you think then that the gravity would be constant when the dinosaurs are around relative to now? How does that expansion of the same piece of mass give you an increase in the amount of gravity? Because that's what we're saying, isn't
Correct,
it?
correct.
Right.
And then this is where we get on to some of what you'll find on the various physics sites, which Peter and I have looked at. Now, you know, Peter does a bit of maths. We've got some calculations in the paper. We've calculated the volumes of the spheres that are involved in this, and we've calculated some of the masses and things like this. But we haven't, for example, you know, the physicists will argue that this idea is just nonsense because all the Earth's mass acts as if it's, you know, concentrated in the centre. End of, you know, this idea that gravity is different in the centre of the Earth or whatever, and you could have gases there. They say that's totally ridiculous because the gravitational force of the outer layers, you know, prevents that from happening. And then we get onto this thing called the shell theorem, which is Newton's shell theorem, which argues and, you know, they would say proves that this idea of what we are suggesting must be wrong, because when you do the calculus, when you do the integration of all the sum of the effects of these little slices or rings of mass, you know, it comes out that they negate each other, and you end up with what is the accepted form of the force of gravity. In other words, when you do a force of gravity calculation on a satellite or somebody at the surface, you use the radius of the Earth as the r in the f gm1 m2 over d squared. You use the radius of the Earth. What we're arguing is that that's not the correct way to do the calculation. We argue that because more of the mass is higher up in the crust and the centre is essentially gas filled, where you haven't got a lot of mass, you've just got the gas, you then get this. If you calculate the force of gravity acting not from the centre but from further out in the shell, that's when you get a lower figure in the divisor at the bottom, so you end up with a greater force.
Right. All right. Well, my understanding would be that if you're considering celestial bodies as masses, because they're so far apart, you can consider them as points of mass with that Newton's equation. But as you get to the surface of the Earth, really, if you've got an object on the Earth, the mass of that object is being attracted to every single piece of mass within the Earth. So you would need to have an infinite number of equations, i.e. an integration from that mass to every point on the Earth, and you'd need to do calculus to do that, right, to work out the force of attraction of a sphere on another sphere. I wouldn't know how to do the maths of how to work out the force of attraction of an eggshell type object to another object, or whether, if the mass is distributed all as one ball, would the gravitational pull be less than if it was a large shell?
Right.
Now,
I
wouldn't know.
I don't know how to do that either.
It's probably some quite complex calculus.
I think it is. Yes, it is some complex calculus, and I'm sure there's, you know, maybe a viewer that can do that and help us with that.
But you have Peter and Andrew have authored 2 papers on this, and you have done some calculations on that.
Yes.
Yeah.
We've done it. We've done like Peter's have done like an approximate integration method just by using a spreadsheet. So we have tried to do it in a slightly different way to illustrate, you know, what we're making the argument for. But what we, you know, putting the calculations aside for a minute, it's well known that we do have gravitational anomalies, and they've been measured. I mean, we've cited a couple of papers. There's a paper about the different, or an article rather, about the different forces of gravity. The greatest force of gravity measured on the Earth. They did a survey 2 or 3 years ago, and they found that where the strongest force of gravity is and the weakest force of gravity is, and the weakest that they've managed to measure is 7,000 meters up a hill, I think, in Peru. And so it is well known that we have these gravitational anomalies. Now, as we were discussing earlier, Richard, my understanding, if anyone wants to correct me, that's fine, but my understanding is that that's how they prospect for oil. They look for gravitational anomalies because the different rock formations have different forces of gravity, and they can measure sort of microgravity, and that's how one of the ways in which they find oil fields.
Yeah, tiny changes in the gravity.
Right.
Would you not get that with a solid Earth?
Well, you would, but we would argue it's more pronounced,
Right.
because you've got this gas-filled centre.
Mhm.
And of course, one of the things that I haven't said with this gas-filled idea is that we've got this transition layer where we've got the gas in the centre, and we've got this, like, what we call the boiling layer. So outside of the gas, you've still got this layer of water which is boiling away. And so what we would argue is that if we had this core of ice in the Earth's centre, and it was there from day one, basically, when it coalesced, that's where the oceans came from. In other words, when we get a crack in the crust that's sufficiently big, for example, caused by a cometary impact or some catastrophic failure of a crustal region, out comes the oceans gushing into and forms the deep oceans.
Yeah, and it also explains why the continents seem to fit together.
Exactly, and that is what that's why Maxlow and Neil Adams' research, they illustrate that so well, that the continents, we didn't state the obvious on this yet, but if you look at the globe, everyone's seen, as I said earlier, that the coast of Africa fits to the coast of South America. But when you do what Neil Adams has done, the continents also fit on the Pacific side as well, not just on the Atlantic side. If you go the other way, they all fit together.
So it's hard to believe that they were just moving about. It's
Right.
suggesting that
Right.
they were once like that and they've gone like that.
Right, and I mean, I've got an animation which I show in one of the presentations, which is the standard, what they call the Pangea model. But they say that these continents were kind of randomly floating around, crashing into one another. And if you look at their animations from some of the university website, they do actually start to look a bit ridiculous, really.
Right. All right. More on this after the break. Welcome back. I'm talking to Andrew Johnson about the evolution of planet Earth and how it may have formed, and the work of Peter Woodhead, who has come up with quite an interesting theory which seems to tie everything together. Now, just tell us about. Is there any other research which suggests there might be, say, underground oceans or water under the ground?
Well, this is a key one, Richard, because we had one of those weird synchronicities in that I took quite a long time to go through this with Peter. He'd sent me a lot of the calculations, some of which he'd redone. And, I knew that I needed to go through this carefully. We put these calculations together. I threw some of them out. I sort of adjusted some of them. I reformatted them. I didn't really change anything of the essence of what Peter said, because I think he was right. But then we made a YouTube video. We posted this video. I posted this video. I think it was the 12th of June 2014 when I posted this video, and we talked about the origin of the oceans possibly being the result of this ice core originally. And then we found that there was an article published in New Scientist called, and the title of it was Undersea Ocean Discovered. And they put this depth of it, and Peter had calculated where he thought this boiling layer was, and I think the depth was around about 400 kilometres. And guess what? The New Scientist article said this undersea ocean was discovered at a depth of 400 kilometres.
Right.
And why they'd come out with this is they'd come out with this research because of a mineral called a mineral or a rock called ringwoodite. And ringwoodite is like a type of rock that I think is about 1 or 2% water. It's actually got water in its structure.
Yes.
And if you calculate the thickness of this layer which they'd given, and then you calculate the total volume of that layer based on the current circumference of the Earth, and then you multiply that by 1.2%, the volume of water that you come out with is still greater than the volume of all the oceans currently on the Earth. So in other words, the volume of water that's still down there in this ringwoodite layer is greater than the current volume of all of the Earth's oceans, I think by about a factor of 5. And these are things that I think they calculated, and we'd done similar calculations too, just on, it's basically simple volume calculations, it's no more than that.
So you think that's acting as some sort of buffer?
Well, essentially what Peter had said when we originally did this idea that the Earth was a frozen core, and then outside of that you'd have this boiling layer. So outside of, and when that had all gone, you'd essentially have this layer of what we called slush. He called it slush because it wasn't water and it wasn't ice, it was something in between. So we didn't know what to call it, but this ringwoodite fits that description. It's not water but it's not ice, and it's not. But it's, in this case, not totally rock. It's got water in it, so it's a water-bearing rock, which obviously would be the perfect medium for where this water was what actually was under the crust of the Earth. So in other words, the simple statement of that article was that there's a lot more water lower down underneath where all these volcanic layers are. Where the hot lava comes out. There's actually water below that. And this was something which was never really discussed that much until quite recently.
So let's just consider what you're saying then and go down through the layers. Can we do that? We've got the Earth's crust. You don't refute that.
Correct.
And as you get further down, tell us what you...
well, obviously we can see from volcanic activity that we've got hot layers of molten rock, not too far below the surface. And you get what they call magma coming out of volcanic craters, which is maybe, I think, goes down to about 4 or 5 kilometers below the surface or something like that, but only in certain regions of the planet where you get this coming out. So we've clearly got hot material under the surface at certain points in the planet. But if you try and go below that, I think the deepest borehole that's ever been drilled anywhere, I think, is something like 7 kilometers deep. So they've only ever drilled down the 7 kilometers to actually sample rock and materials that are there, and it does get quite hot down there apparently.
Right.
But below that, what they're going on is seismic readings. So they fire these, they set off charges or whatever, they wait for earthquakes, and they make seismic readings, and these then allegedly are refracted through different layers of material, and the seismic readings end up being picked up at different stations. And it's a bit like an optical method where light is refracted through a lens and different types of medium.
Different types of wave will travel at different speeds
exactly.
through different mediums.
Through different mediums,
so they can try and guess what material it's made from.
Right, and the wave will get refracted, and it's the same. That's how they do seismic readings, and that's how they've allegedly deduced that there are different. There's a liquid layer lower down, and I think they say there's a liquid layer of iron at the centre because that absorbs some of the seismic signals. So
are you saying then that the water that's inside the planet, which may be high pressure steam now, can then bring about magma and volcanoes? Can steam get that hot?
Well, not exactly, because what we would argue is that the heating is going on higher up in the crust. In other words, as you go down through the layers, as you were sort of suggesting, initially it's hot, but then it'll start to get cooler. So when you get closer to the centre of the Earth, you've actually got a cooler layer, and the centre will be probably a relatively cool gas. Certainly not much. I don't know. It may be hotter than standard steam because we don't know how much pressure is there. But we're not dealing, as we would argue, with a high density, hot, high pressure, molten iron and all of that stuff. We don't think that's there. We think that the Earth's magnetic field, for example, is produced by another method.
Now, that brings us nicely onto other theories that I've read about, the hollow Earth. Because is that essentially what you're saying or not?
Well, it's similar to that, and this is why I wasn't, when I initially came across this, I wasn't initially attracted to it, because I thought there's no way the centre of the Earth is hollow, because that just, the density measurements and so forth would not allow us to have that. But when I've looked at it more thoroughly with Peter's research, I do think, well, maybe yes, the Earth is hollow inside. But then you get into these other sort of areas of more contentious things, like the trip of Admiral Byrd. Did he go into the hollow Earth? And Olaf Janssen's story. And I covered all of that in another presentation, and we're not going to cover that here because, frankly, there isn't time. But my summary of that is I don't think that we've got this situation where people inhabit the inner Earth. There aren't these races there, I don't think. Certainly not at the depths of thousands of kilometres. There may be various cave systems which are a few kilometres down which have people living in them, for all I know. But this idea of having a whole race of extraterrestrials living inside of the Earth, and there's various passageways to that, I don't currently go with that idea.
Right. But let's just say then, let me just draw for this, because I can't get my head around the maths, because it's a calculus. So let's just say then you've got a sphere which is hollow, but it's got a certain thickness to it. Yeah, I've drawn my sphere there. Okay. Okay, we're on the surface there. Yeah. what would happen if you were inside there like that? Would there be gravity pulling you down there, would you say, or
what would happen,
or would you float towards the middle?
You would essentially float towards the middle, much as you see in that NASA video, because
right, yeah. So we'll go back to the bubble.
Yeah.
So something which is quite massive or got heavier than water, say.
Yeah.
It's gonna. Well, no, you said it would go to the edges. Would go to the edge, and
so in other words,
but the gas, the bubbles would go to the centre.
Yes.
So it would depend on your mass whether you would go towards the outer or the inner.
But it all gets very complicated because it's not something we can eat apart from the bubble experiment in the NASA space station. It's not something beyond that we can easily reproduce experimentally. This then gets us onto the whole idea of how gravity works. We make certain assumptions about gravity, but it is true. Whatever we said in this program, nobody quite understands, at least in the white world, what produces the force of gravity. And this has been one of the major sort of quests in physics, as to explain where it comes from.
Yeah, it's Newton's law of gravitation is an observation, not an explanation.
Yes, and it makes predictions about what will happen when you throw an object or you project it at a certain speed away from another body of a certain mass and all of that. And it does appear to sort of be fairly accurate for that. But what we then got onto, and this comes onto it very recently, that was a chap that contacted us about what's called the electric universe theory, and he was arguing that the force of gravity is a result of, well, this is what the electric universe theory says. This is Wallace Thornhill and David Talbot that have come up with most of this, mainly Wallace Thornhill actually, and he argues that the force of gravity is produced by dipoles, essentially in atoms. And if you look at a video he's done called The Long Road to Understanding Gravity, which was only posted in the summer of 2015, he goes through this idea that the Earth's gravity is produced by dipoles in the Earth's the mass that's makes up the Earth. And he actually puts a picture up where he thinks that as you go towards the centre of the Earth, the force of gravity changes, and you will actually get a kind of a negative force of gravity as you go into the Earth and you go in towards the centre. So in other words, without he's not spoken to us about this, but he actually agrees with the proposal that the Earth wouldn't be a solid mass at the centre, that the gravity would work differently.
All right, Andrew. Well, mind-boggling stuff. And we're going to talk more about the impact of this theory on the universe and the wider solar system after the break. Whoops! Tonight's show was so mind-boggling that I lost count of how many parts we'd filmed. If you want to see the final part, you can watch it online at richplanet.net. See you next week. Welcome back. I hope you're all following it so far. I'm with Andrew Johnson and we're talking about an alternative theory which would explain the evolution of the Earth. Now, you mentioned the electric universe theory, and I've heard it said by many people who are perhaps linked to the military-industrial complex that electricity and gravity are inextricably linked, the subject of electrogravitics, which is what certain secret propulsion systems perhaps work on. And we might even mention the UFO phenomenon. But let's stick to planets for the moment, because I said at the beginning that this theory might explain why the Earth would eventually become a gaseous planet or a gas giant,
right?
If it was to continue expanding as you believe it is.
Right. Well, this I think does not only does the gravity effects tie in with the electric universe, as we mentioned before the break, But also one thing I wanted to mention earlier, and it's appropriate to mention it now as well, is that the heating that we talked about, which actually melted the core originally, where did that heat come from? Well, we mentioned radioactive isotopes, but another possible area is what are called telluric currents, which are these currents that are induced in the Earth's crust by the electrical field associated with the sun, which isn't generally acknowledged. So if you consider that the sun has an electrical field as well as a magnetic field, or even if you just take that it's got a magnetic field, and one might argue that the Earth is moving around the sun, and indeed it is, and then as it's moving around the sun, it's moving in either an electric field or a magnetic field or both from the sun, and therefore you're getting these currents induced in the ferrous materials and metallic materials and the metallic ores in the Earth's crust. So that in of itself is going to create more heat. Right. Now that might be that we can never measure that heat because it's too deep down in the Earth's crust. It's something we'd never be able to measure directly. So if we then say that heat source is while the Earth is going around the sun, the Earth has always been heated internally, not just from the heat that falls on the surface from the normal infrared radiation and so forth, but we're getting this heating from electrical and magnetic effects. So that is so the Earth is continually expanding.
Well, and think of putting a cup of water in a microwave oven. It's an electromagnetic effect on water which turns it into steam.
Exactly.
Maybe not a good analogy, but
maybe there's some analogy like that which we're not presently aware of, and it's only happening over long periods of time and in small amounts that we wouldn't normally be able to measure. So if you say the Earth is expanding, well, let's just say that Jupiter, for example, was formed. It's much bigger, from a much bigger original mass, so there was maybe more ice there. And the way that heated up, it heated up much more quickly, expanded much more quickly, and thereby it's become a gas giant. And essentially what's happened is the water that's in the water that was originally in the core has now all come out of the core, and because of the original mass that was there, the gas has been still held by the gravity around the planet. So what was in the core is now a gas around the planet.
Right. And you think that that's what might eventually happen to the Earth?
It's possible, because we've still, based on this article in New Scientist, we've still got a greater volume of water down underneath the crust than the current volume of the oceans altogether. So it would depend on how much heating there is as to what actually happens to that water.
And is there any evidence that any of the other planets in the solar system are expanding as you think the Earth
Well,
might be?
we would argue that there is, because again, if you look at some of the, certainly not so much the planets, so we've talked about the gas giants just then of Jupiter and so forth, but if you look at some of the moons, maybe these are all undergoing the same process as well, and this is what we found quite recently. I think about 4 or 5 years ago, they announced that Europa, which is one of the moons of Jupiter, that was venting water vapor. It was coming out of the surface, and they photographed that. Ganymede, that was also found to be emitting water, venting water, I think in 2003. So was Mimas, which was a moon of Saturn. That was found to be venting water. We've also put in the more recent, second article, that the moon, they've now found recent volcanism on the moon, I think in the last, something like the last 100 million years, which appears that there are cracks in the crust of the moon, and hot material has come out from within. So the moon isn't quite as dormant as they would have you believe.
And possibly hollow.
And possibly hollow. We've had, for example, this phenomenon of transient lunar phenomena, which is something I learned about almost 30 years ago when I used to go to the astronomy club. Amateur astronomers have seen clouds of gas on the moon that come and go, and coloration, in parts of the moon that comes and goes. So is this another indication that there is this expansion in the moon still going on, and these indications that we see are, a result, these clouds of gas and so forth, are a result of what's coming out of what's inside the moon and so forth.
All right, and just to go back to the subject of plate tectonics then, because I've heard you in the past, quite some time ago, probably before you, I think, it would have been before you even met Peter Woodhead, poo-pooing the whole science of plate tectonics. Just tell me why you think it's a flawed scientific theory?
Well, I think what they've done is, again, it's kind of limited hangout. It's not. I mean, I think that the basic idea is correct. That you've got these continents moving around, and they're moving around on a substance which is more liquid. It's kind of floating. But they claim that the Earth is a constant size, so they've had to invent this subduction idea, where you actually end up with something of greater density, or something of less density going under something of greater density. So the lighter material sinks into the heavier crust, which doesn't make sense, based on their own physics.
Now, let me put this question to you then. If the Earth's gravity works different to the accepted model, well, not works different, but the Earth is different internally to the accepted model, which would mean that as you get further out from the Earth, if you work out the gravitational attraction between, let's say, a satellite and the Earth, it would have a different profile.
Yes.
From a shell shape compared to a solid sphere.
Yes.
So when they're launching satellites, for example, would they not notice that the gravitational pull that they've calculated is different when they're putting their satellite in orbit?
Right. I mean, that's a very good question. I mean, because I don't put satellites in orbit myself, and I don't know anyone that does, I don't have somebody to ask that very sensible question to.
I know someone who's tried.
Yes, well, you featured him in the programme, and it did come to mind. I know he was sending stuff up there, but I don't know if he was trying to put stuff. I suppose ultimately
that was his ultimate goal.
Yeah. In orbit, wasn't it? Yeah. But from what I've seen, for example, there's a story on Richard Hoagland's website, Enterprise Mission, about the Explorer 1 probe, which, if my memory serves me correctly, went up in 1958, and that was only a year after Sputnik. So it's the early days of the White World space program. And that probe, when they were monitoring it, was 12 minutes late, finishing its first orbit, which indicated to me that it had gone up too high. It had gone up higher than it should have, based on their calculations. So that would mean that potentially the force of gravity that they were, assuming was working on that probe was stronger than it actually was, because it went too high. And then also, as Peter had mentioned to me in one of the interviews, and I checked this out, if you look at some of the early probes that were sent to the moon, quite a few of them crashed. And we have to wonder if the forces of gravity which they'd ended up calculating had a small percentage error, maybe only 1 or 2% or something like that.
Right.
And that then therefore caused these orbital calculations to be incorrect, and that's why these probes crashed. So we wondered since then, do they add in a fudge factor of some kind? Which
right,
we're not aware of.
they could factor in an error in order to correct once it's approaching the orbit.
Right.
I guess they could do that.
They could do that.
But so do you think then that, let's just assume this theory is correct, right? So do you think that in the military-industrial complex where they've actually figured all this out and they just let mainstream science plod along with its plate tectonics, or?
Well, I think that this actual theory itself probably doesn't make a lot of difference to their agenda in of itself. I think where it, would make a difference is to do with the electric universe stuff, and how it may reveal certain things about the interaction between, or relationship between, electricity and gravity. I think that's where they would be more concerned about it, in those areas, not so much in the formation of the Earth. I don't think that's a big deal for them.
Right, I see, but which could link into both weaponry and propulsion.
Yes, in terms of, yeah.
Do you want to touch on either of those, Andrew?
Well,
I mean, I know I've digressed a little bit there.
Well, I mean, it's just in terms of, if we're looking at the way gravity works, and if there is this electrical relationship to electricity, then they're probably not going to want to talk about that. They're not going to want to talk about this, any type of relationship which might reveal how a new type of propulsion system might be engineered, or a different type of weapon system might be engineered, such as we've spoken about at some length, as it was on 9/11, that weapon system, which clearly operated on a completely different principle to ballistic weapons, and even these more recent developments with hot directed energy weapons, such as the laser systems that they've been using on some of the ships and tanks and so forth.
Mm-hmm. If we can just finish on that argument then, Andrew, there's been a lot of rhetoric at the moment. Before I mention that, let's just give credit to Peter Woodhead, because I think he's done some sterling work there.
He has,
you know, really sort of boggled my mind when I saw that interview with you, and I thought it was very, very interesting. But just to come back to what I was saying, there's been a lot of rhetoric in the media about Russia and Putin, and they've got nuclear weapons, and we can't get rid of Trident. And when you look at what happened on 9/11, and you consider that all the evidence in Dr. Wood's book that suggests that they have weaponry which is completely different to nuclear weapons. So nuclear weapons ain't going to protect you folks against what was seen on 9/11.
Right. And I mean, one thing I will say on that, and it's in my book, is that we got quite concerned in 2007, when I say we, myself and Dr. Wood, when we found that Stephen E. Jones, the physicist, and there's a chapter about this in my book, it's called The Touch of the Hidden Hand if people want to read about this, he was saying the same sorts of things as Michael Chertoff, who was then the head of Homeland Security, in that they were thinking that Al-Qaeda would smuggle nuclear devices into America and blow up a city. And what we thought was going to happen at that point, or we didn't think it was going to happen, but what we thought they could potentially do is, because, as we've seen on the internet, the effects of the weapon at the World Trade Center looked like a nuclear bomb's gone off. We thought, maybe they're going to try and, you know, use the weapon again on some American city or somewhere else and give these effects which look like a nuclear bomb has gone off, and then blame it on Al-Qaeda nuke.
Right.
And then they've now repeated that recently. They've been saying that ISIS could have access to nuclear weapons, or Russia's going to set off a nuclear weapon. So my concern was that they were going to nuke somewhere, but it wouldn't be a nuke. It'd be the weapon that was used to destroy the World Trade Center, used in a slightly different mode or in a slightly different way. And then they will blame it on Russia, Al-Qaeda, or whatever they needed to blame it on, when it was nothing to do with that.
Right. All right, Andrew, and if you want to check out 9/11 and Andrew's other research, it's Andrew's website is checktheevidence.com, and Dr. Judy Wood's book is Where Did the Towers Go? But thanks for joining me today, Andrew. It's been a fascinating discussion. I hope you're all still awake. And remember, believe none of what you hear, including what you learn at school, and only half of what you see. I'm Richard D. Hall. Good night.
For inviting me.
Okay, now some people occasionally say, well, why do you keep having the same guests on, Richard? And I would answer that by saying, well, because the guests that I have on always talk about something new. Okay, you've done a lot of research into 9/11, the moon landings, Mars, and we've covered many issues. But this is a completely new area, at least for RichPlanet, and I think it's a fascinating theory. And we're going to mention the work of Peter Woodhead as well, who you've been collaborating with. Now, what impressed me about this theory, Andrew, is that it seems to explain many loose ends about our planet and possibly other planets. And I'm just going to list some of them that I've picked out when I've seen the interview that you did with Peter Woodhead, and also the papers that you've written with Peter Woodhead. Now, I think it could explain why larger planets are gaseous or become giant gas giants. It explains why the gravity of the Earth was much less when the dinosaurs were around, which a lot of people think. It explains that in the past, when the Earth had less gravity, when the dinosaurs were around, but the total mass of the Earth was still the same. It explains why some of the ocean...
During a period around that time, there was what they call bombardment, where you had these lots of debris flying around, you know, which was making up the other planets, the moons and so forth, and that was repeatedly coming by and crashing into the Earth, and a very kind of hellish environment, and we ended up with what allegedly we have now, which is a fairly cool crust, outer crust, and then we have, you know, a breathable atmosphere. And then if you go further down, you know, if you were to drill down through the Earth, you'd go through the sort of layers of rock and so forth, and then as you went down, it'd get hotter and hotter and hotter. And then my understanding is that they say we have a molten core of iron. The core of the Earth is molten iron, because the story is that the iron is heavier than a lot of the other elements, and it's ended up basically at the core of the planet, and it's essentially liquid. And my understanding is that the reason, one of the reasons why they say that this is the correct model, is because that gives the Earth its magnetic field. So in other words, this molten core is in whole or in part responsible for producing the Earth's magnetic field.
Volcanic plates are relatively young. It explains why the Earth has oceans. It explains how the continents formed, and it also explains why the continents all seem to fit together. Now, but before we go into the actual theory that we're going to discuss today, just give us your understanding of what the accepted theory is on how the Earth came to be where it is, like it is.
Right. Well, I mean, you know, what I remember reading about many years ago, and I have to obviously point out that I'm not a geologist, I'm not a planetary scientist, as we've discussed before, Richard. You know, my background is in software, although, as you said, we've investigated these other things together in these various programs. So, you know, if I get some things wrong, then please forgive me. You know, I wish I knew everything about these topics, but I don't. But my understanding of, for example, how the Earth was formed is that there was a large accretion of mass from which the Sun and the planets either formed or were forming, and that was initially largely, you know, hot mass, and then at some point the Earth formed into a distinct body which was still very hot, and, you know, you had periods of hot material, a globe of hot material essentially, and
right. In this diagram that you referred to there, that we see in many textbooks, you think is possibly completely incorrect.
Potentially it is.
Potentially.
Yes. Yeah.
Now, let's briefly talk about Peter Woodhead, because really, he contacted you with this theory, and his theory was built upon two other researchers.
Yes.
They are James Maxwell, is it?
Yes, correct.
And Neil Adams. Now,
essentially, yes.
Right. But Peter had actually, well, his theory is different in one very fundamental respect to their theories. We'll
go through that.
We'll explain their theories in a moment. But one thing that, because I've met Peter as well, Yorkshireman, and I think he's from Yorkshire.
I don't know. It's Lancashire.
Lancashire.
So, yeah.
I'm going to get wrong for that.
Yeah.
It's on the Yorkshire border somewhere.
Yeah, it's close to Yorkshire.
Yeah.
Not quite near my old stomping grounds, actually. Yeah.
Right. Now, Peter said that he'd watched one of my shows where I interviewed Keith Hunter.
Yes.
Now let's, and you can watch those interviews there. Welcome to RichPlanet TV. I'm Richard D. Hall. How much of what you learned at school was true? In today's show, I am going to be discussing with Andrew Johnson a new theory about the development or the creation of planet Earth, and possibly all planets. Many observations about the Earth over decades have puzzled scientists who have concocted theories to attempt to explain what they observe. including theories such as plate tectonics, or the Earth's core is made of iron, or the primordial Earth was much hotter than today, etc., etc. Now, if the new theory we are going to talk about today is true, it means many textbooks will need to be rewritten. I'd like to welcome onto the show Andrew Johnson. Welcome back, Andrew.
Great to be back here, Richard, in the new wonderful studio. It's very impressive. Thanks.